China's naval research and industrial sectors are moving methodically toward a future in which uncrewed systems play a central role in maritime operations. The emergence of the small, open-deck vessel now serving as a drone testing platform reflects both technological progress and a change in how China is approaching experimentation at sea. This vessel, described by observers as a mini-drone carrier, embodies a design philosophy that emphasizes flexibility, rapid testing, and adaptation rather than traditional naval strength or endurance. Its appearance marks a point where the country's extensive investment in autonomous aviation and shipboard systems is beginning to show tangible results. The ship itself measures roughly 100 meters in length and around 25 meters in width, dimensions that make it large enough to host vertical takeoff aircraft while remaining compact enough for efficient operation and easy modification. Its deck layout includes a flat, open surface and a small island positioned on the starboard side, providing basic command and control facilities. The markings and trapezoidal configuration on the deck suggest deliberate planning for vertical takeoff operations, such as those performed by rotorcraft-type drones. Unlike traditional carriers designed for fixed-wing aircraft, this vessel focuses on rotary wing and other vertical lift systems that can operate within limited deck space. The construction of the vessel at the Jiangsu Diang Marine Shipyard aligns with that yard's growing reputation for developing experimental hulls and unconventional support platforms. Over the past few years, that facility has produced a range of craft specifically meant for research, testing, and training purposes. These ships are not designed for combat but to explore how new technologies perform in realistic sea conditions. The mini-drone carrier continues this pattern. Its link to the China State Shipbuilding Corporation places it within a framework of coordinated state-sponsored innovation, which connects shipbuilding expertise with aerospace, communications, and control system development. Testing aboard this ship has centered around the AR-500CJ, a small rotary-wing uncrewed aircraft engineered for maritime environments. The AR-500CJ represents a progression from earlier uncrewed helicopter designs, offering more robust flight control systems, improved corrosion resistance, and fuel types safer for use aboard ships. Its autonomous landing and takeoff trials from the vessel demonstrate progress in precision navigation and automated recovery systems, areas that are technically challenging due to wind, deck motion, and magnetic interference at sea. These tests show that uncrewed helicopters can perform steady operations from ships under realistic ocean conditions, which is an important capability for surveillance, data relay, and reconnaissance roles. Beyond these specific trials, the vessel's broader significance lies in its role as a modular experimental platform. It can host different equipment packages, communication networks, and control systems as technologies evolve. For example, one test period may focus on deck handling automation, another on secure data links between air and sea platforms, and another on fleet coordination between multiple uncrewed vehicles. Because the vessel is smaller and simpler than an operational warship, it allows frequent changes to layout, wiring, and control interfaces without affecting fleet readiness or disrupting military deployments. This flexibility is crucial for iterative development, where feedback from each test cycle leads to rapid design refinements. The creation of a purpose-built drone test ship also reveals how China is organizing its research structure. Instead of relying only on land-based testing or adapting existing ships for temporary trials, Chinese engineers are now using dedicated maritime laboratories at sea. This approach mirrors how advanced industrial powers develop naval technology, by separating experimental infrastructure from frontline assets. Doing so reduces risk, speeds up certification, and allows simultaneous progress on multiple systems. It also means that data from the mini-drone carrier can directly inform the design of larger vessels expected to integrate uncrewed systems in the future. Strategically, this development contributes to China's goal of enhancing its ability to monitor and manage large ocean regions. Uncrewed helicopters can extend the visual and electronic coverage of surface ships far beyond their onboard sensors, providing continuous awareness over the horizon. They can relay signals between vessels, coordinate small surface drones, and serve as test platforms for artificial intelligence systems that handle navigation and data processing. By perfecting such operations on smaller test ships, Chinese researchers can later adapt the technology to major fleet units like destroyers or amphibious assault ships. The mini-drone carrier also highlights a shift in design thinking. It suggests that future maritime forces may rely less on a small number of large, heavily armed ships and more on distributed systems that share data and coordinate automatically. A fleet that includes uncrewed aircraft, surface drones, and modular support vessels could operate more efficiently and at lower cost while maintaining situational awareness across wide areas. The experimental ship is therefore not only a testbed for hardware but also for tactics, logistics, and command methods adapted to a more networked form of naval operation. From an engineering standpoint, operating drones at sea requires solving complex problems in stability, control, and communication. The ship must maintain a steady deck motion, provide reliable power supplies for charging and maintenance, and ensure secure data links even in adverse conditions. Every successful trial represents progress toward mastering these challenges. Each stage of experimentation contributes to an understanding of how uncrewed vehicles interact with the marine environment and with human-operated vessels. That knowledge will later feed into both design and doctrine. While this vessel's activities are focused on research and training, the broader program reflects a consistent pattern in China's technological planning. New capabilities are developed gradually, through sustained testing, until they can be scaled up into operational service. The mini-drone carrier's existence confirms that uncrewed naval aviation is no longer theoretical for China but a field in active, organized development. Over the next few years, the lessons learned from this platform are likely to influence how larger ships are equipped and how future naval operations are structured. The ship thus represents both a physical experiment and a glimpse into the evolving structure of maritime innovation.